So in today's lecture, we'll see the calculation of HPLC validation parameter. We'll check the validation parameter of HPLC of Remilton. We'll check the parameters including system suitability, linearity, accuracy, precision, robustness, and ruggedness. So for transparency and for availability, we have uh, put the values that we have already got from our result after HPLC analysis. That includes the peak area, tailing factor, theoretical plate, retention time. So one question may arise that how I have gained these data. Actually, after analysis, we have got some sorts of these peaks. Okay, these peaks tell everything regarding the retention time, area, theoretical plate, any other things. Okay, so after the analysis, we put the values. Okay, actually, what we get in HPLC data, we get only the peak area, tailing factor, theoretical plate, and retention time. Okay, so these are the values that we get from HPLC, and we need to do analysis by using this data. So let's check. First of all, I'll talk about linearity. So what is linearity? Linearity is the uh, tendency of any HPLC method to provide a consistent result in accordance with its concentration. Okay, for example, we are using different concentration like 50, 40, 30 microgram per ml, 24, 20 ppm, 60 ppm, different concentration we are using, and accordingly we have got different values. Okay, so according to the HPLC result, I have put all the values here. Now we'll check the uh, peak area, or we'll analyze this. We'll analyze the linearity, accuracy, precision, whether they are in within the ICH guideline or within limit. So let's start. First of all, how we'll analyze this. In that case, we can see the linearity peak area was 3, so we need to get the average. So average is here, so we'll just click on that, and after that we'll paste this here. Okay, same the average of the three are shown here. We'll just click on that and we'll paste it here. Then for the concentration of 30 ppm, the average is here. We'll click this and we'll just paste on here. For the 24 concentration, we'll get all of the values. Then we'll click here and we'll paste here, and as like it, just click and get the result. We'll select get, and you can also do this by using calculator or any other process in the Excel, but this is one of the most suitable method for getting the average. I'm just putting and clicking. Okay, so I have put all the average value here, and now it's time for getting the percent RSD value, because ICS guideline uh, tell about the percent RSD value. Okay, so before getting the percent RSD value, let me check another thing. I'm putting all the area here for further calculation. Let's put the area. I'm putting every value here. This is for 0.2. I'm putting all the values here. This is for getting the linearity. Okay, we'll see how linearity is measured. This is for 10. This is for 12. Then this is for 16. We have done serial dilution, and we are putting the values accordingly. This is for 20 and this is for 24. We'll just copy pasting the result, and last one is for 30. So I have put the concentration and their average value, and in the meantime I want to show how we'll calculate percent RSD value. Okay, this is not the standard deviation, but the ratio of standard deviation and mean. So how we'll calculate percent RSD? For calculation of percent RSD, we need these three values, and we'll go in percent RSD calculator. Just uh, go in the percent RSD calculator. When you are going to RSD calculator, you'll just put your data set. I just copy paste them, and from there I got the average and the percent RSD. So percent RSD is 0.005. So for this percent RSD is 0.005. So I'm just putting the value. So I'll just copy pasting this for so our first percent RSD is 0.005. Okay, now we'll calculate others. For these three we'll just copy them and we'll just paste them here. I paste them, then calculate. Now after the calculation 0.015. Okay, 0.015. So by doing the same method we'll check all of the values. Same, we are putting the value here, then calculate, then we're getting 0.013. Okay, so by using the same method we'll put all the value. I'm not showing 0.013. Okay, I've shown the three values. Now let's check the linearity. What is this is the most important thing. So for this we'll click on that and we'll uh, press insert, and from here we'll get the curve, and here please put the axis title, trend line. Okay, so now we need to check the r square value. We'll get this by this technique: display the equation on chart, display r square. Okay, then just we have got the value. So this is our main thing. This should be included in our article. Okay, so in axis title we'll write the x-axis means concentration and y-axis means area. Okay, so this is the overall value. So we have already got the calculation in which we have found out that, so what would be the value of x value would be like y minus, this equation is important for us, 10333 divided by sorry, y minus, and that would be 3169.7. I'm showing this equation for a reason, divided by 10333. So this equation is important. By using this equation, from next we'll uh, calculate the x value. Okay, I'm just putting this here, that is important for us. So that is our value, x is equal to this. Okay, so we'll utilize this to calculate the accuracy and precision and robustness, all the data, all the validation data. So let's check. For the accuracy we need to calculate the amount recovered, then percent recovery. That is the most important thing. So how do we calculate this? So let's start. First of all we have to put is equal to, so how much amount was recovered. So for the amount recovery we need to press equal to, then we need to put the value of area. So what would be the value of our area? Area would be y. The value of y would be the area. So we'll click this minus, we'll put the value 3169.7. okay, 3169.7 divided by, we'll put the value 10333. This is utilizing by utilizing our axis y is equal to mx plus c. We are utilizing this, and at the moment we have to calculate the recovery, because we have added 50 ppm and we are getting 49. That obviously means that we are not getting the 100% product. Okay, so what would be the recovery and how do we calculate this? For this, press equal to 100 plus. So in that case we are getting what? We are getting amount recovered, that is that. Okay, we'll minus this initial value. So minus this initial value divided by this is as like as our yield value. Okay, divided by, it would be divided by 50, because we are working by 50, and after that we will calculate something, we will multiply something into 100, and our percent recovery is 99%. Okay, so in the same method we'll just press the plus sign and we'll just put them below, and we'll ultimately get all the result. Okay, so this is the overall result. We can see here that in some cases the uh, recovery was 99%, in some cases it was 98%, in some cases it is 102%. Okay, so these are the overall value that we have calculated. Now let's see the intraday and intraday precision. So this intraday and intraday precision we have already calculated. We have already put the value of peak area. Okay, so this is our nominal concentration, that is 40 for Hamilton. 40 was our nominal concentration, and these are the area. So for this we have done interday and intraday precision. So let's check the uh, amount recovered. So how we will do the amount recovered? First of all, uh, this is our peak area. Okay, first of all we need to put is equal to, just we will copy paste from there, nothing else. I'm just copy pasting this. So just I'm just pasting this, just put equal to, and put the value of this box. Okay, then we'll get the recovery. So we have added 40 and we are getting 40.1. Anyway, we'll get the percent recovery by how? By 100 plus, then we should use this and minus the actual amount divided by actual amount into 100% for the yield value. Okay, that should be our overall value. Sorry, it should be ended up by divided by. Okay, so that is the overall value. Just put them below and we will get the ultimate result. So in all of the cases our this is our percent recovery. In all of the cases we have got 100%. So one question may arise that how we'll get the average. Just for the average we'll copy this, and the average has been shown here, 100.417%. so just copy this and paste this. And for percent RSD, what will you do? We'll just copy this and paste this in where? In that area. Okay, then calculate. After the calculation we'll get 0.015%, plus minus 0.015%. We are just putting this as a reference, 0.015%. Okay, you can also check the value 100.417%. in the manually you have also gained 100.417%. Okay, so by utilizing these we will calculate rest of them. Now let's check the robustness. So for robustness study, we usually change the flow rate or mobile phase composition, etc. For example, our actual flow rate was 1. We have changed this into 1.1 ml per minute. Our actual flow rate was 1. We have changed this into 0.9 ml per minute. For example, our actual mobile phase ratio was 20. We are changing this into 25%. Our actual mobile phase ratio was 20 and we are again decreasing it towards 15%. We are checking whether variation in flow rate or mobile phase will ultimately change the uh, validity of the method. Okay, so this is as like as the same procedure. What will you do? We'll just copy paste this sign. I'm just copy pasting this. Okay, sorry. I've just copy paste this, just put equal to and paste, and our initial value is 40 because our nominal concentration was 40, and for this reason we are using this. After the uh, calculation we have got this, then after that we'll use the percent recovery. So how we do percent recovery? That is 100 plus, that was our amount, so we'll minus from this minus 40. Okay, because our initial amount was 40, so what will you do? We'll divide this by 40. Okay, ultimately for yield value we calculate something into 100, so that is our ultimate yield value. Just our main function is to do the same calculation for all of the, yes, we have done the same calculation for all, and if you check, you will easily find out the result that whether for this the calculation has already been preserved. Okay, that is just the case. Okay, and after that we'll calculate the ruggedness of our study. So this is the same procedure. How do ruggedness measure? Ruggedness measured by different analysts. Okay, for example, one analyst do this method and he found out this result, then analyst 2 has found out this result and putting the value here. So this is also same procedure as like that. Just we are putting, for example, we will put is equal to amount recovered. Then what will you do? We'll just uh, y is equal to mx plus c. Okay, so y is equal to mx plus c means we'll just copy paste this, because for y is equal to mx plus c, here we are just putting the value, like I'm just copy pasting this, nothing else. I'm just copy paste this. In that area we'll use this. Okay, I've used the box, and for the recovery, what will you do? Just we'll copy paste this. Okay, we'll copy paste this, and we are equal to and putting the value here, and for this value we'll use this and enter. So this is showing the recovery. You already see we are using the 40 and we have got 40.1. That means our recovery more than 100. That is 100.4. And what will you do now? We'll just click in that way, and our all value have appeared. And this time we'll see the average. So how will see the average? Average is already seen 100.4. Okay, we'll put in the average and we'll see the percent RSD. So how percent RSD? We have copied this and then we have paste this, then calculate, then we'll get the percent RSD here. Okay, 0.012%. Also see the mean. The mean is 100.42%. Okay, so 0.012%. Just we have copy paste this. Okay, so by this method we can put the values. So these are the overall calculation of our robustness, ruggedness, intraday precision, linearity, accuracy. So now let's jump into the system suitability. So what does system suitability means? So system suitability, as the name suggests, it means the suitability of the system. Okay, suitability of the HPLC system. So how it gives the peak area, tailing factor, theoretical plate. So these are the system suitability. So peak area, we have got 6 peak area. We should put the mean and RSD. So the mean has already shown here. We are pasting this, and RSD would be calculated by what? We'll check the RSD by our manually. So we're pasting this, calculate and check the RSD, that is 0.017%. So we'll put the RSD value here, 0.017%. Okay, 0.017%. We'll put the RSD 0.017%. So what was our criteria? Our criteria was to be less than 2. Okay, it is less than 2, and this is also as like as tailing factor. We can get the average here, and we can also put the RSD value by the same method. It should be less than 1.5. Yes, our tailing factor is less than 1.5. Then theoretical plate. So theoretical plate means theoretical area where the ultimate separation takes place in the column. So it should be more than 2000. Okay, our theoretical plate is much more higher. Okay, it is 4200. And then the retention time. Okay, our retention time, sorry, I have yes, our retention time was 1.4. So how did I got the retention point? Here is the retention point. You can see this is our Remiltion. This is the retention point, as you can see, 1.41. Okay, so there are other peaks. Okay, in that the retention time is 1.43. We have put all the values here from the data that we have got. Okay, so that is the ultimate progress that we have made. So in case of retention time, we are also getting the average, and we are putting the average here and just copy pasting this. we will check whether its RSD value is within limit. So let's see the RSD value. The RSD value is 0.466. So let's see what was the criteria. It should be less than 0.5. Okay, our RSD value is 0.466. So I am just putting this here, 0.466. So it is less than 0.5. Okay, our RSD value was also good. And these are the overall validation parameters: the system suitability, linearity, accuracy, precision, robustness, ruggedness. We have calculated all the values. Okay, our linearity was also very good, because you can see here that its R square value is 0.999. Okay, that is very higher, although some of the values are just out of the uh, line, but overall the value is good. Now we'll check the degradation parameter. We have also checked different degradation parameters like acid degradation, base degradation, hydrolytic degradation, oxidative degradation, photolytic degradation, thermal degradation. We conduct these degradation studies. So let's check how we'll calculate this. This is as the validation study. For degradation, acid degradation, we conduct the degradation in room temperature 40 degrees Celsius or 60 degrees Celsius for 1 hour. And this is our nominal concentration. So how did we get the nominal concentration? Nominal concentration is the concentration that we take for uh, daily analysis. So for Hamilton it is 40, and these are the peak area. So how did we got the peak area? We got the peak area from the peak, okay, from the data that we gather from the HPLC. So let's check the amount recovered or any other values. So how we'll check amount recovered? First of all is equal to, then y value, we'll put the y value here. Okay, sorry, we'll put the y value, that is y value is that. Okay, so minus, then we'll put this value 3169.7, bracket closed, divided by what would be the value, the intercept 10333. Okay, yes, 10333. We got the value from the axis. So amount recovered is 37. You can see we have added 40 and we are getting 37. Okay, so we have lost something. So it's time for getting the recovery. So for recovery, how do we calculate this? For example, 100 plus, then how much did you get? 37 minus how much did you add it? That is 40. So divided by how much was the initial value? That is 40 into 100, because it is percentage. So okay, into 100. So that is 93%. You can easily understand that you have added 40 and we are getting 37. So ultimate value will be less than 100. Okay. So what it be our degradation? We have recovered this. So our degradation would be just nothing but 100 minus what? 100 minus this recovery. So we have gotten the degradation, that is in 1 hour 40 room temperature, the acid degradation is 6.5%. So just click this and do that. We have got the degradation. We'll check the average degradation. So average degradation is for this 6.51. So we'll put 6.51, and for this our value is, then for these three our value is this. Just we are copy pasting this. So we can easily check that in room temperature it was 6% degradation, in 40 degrees Celsius it was 30% degradation, then in 60 degrees Celsius degradation increases more. So these are the overall approach by which we undergo this degradation. We can also do our overall degradation like base degradation, hydrolytic degradation in the same method. Okay, HPLC will provide you the peak area. You'll just put the value in the table and ultimately get the result. So these are the overall approach for the validation and degradation using the HPLC method. International Conference on Harmonization, that is ICH, put the analytical method. Okay, and they declared these analytical tests to be performed. Okay, that's why we are undergoing these analytical tests using the ICH guidelines. So I think everything has become clear to all of you. If you have any confusion, please inform me in the comment section. Thank you.